Hello students, this is part 2 of lesson U6A01b. By the end of the lesson, you should be able to say I can find radian measures of an angle. Now, part 2 of this lesson is we are going to work with, again, the formulas involving arc length and area of a sector of a circle. So if you recall from two previous videos, lesson U6A01, we've gone over how to find the arc length and area of a circle if given something in degree measures. So now what we're going to do is we're going to rewrite those formulas in terms of radian measures. And you're going to see how useful and how much cleaner the application of radian measures is in these formulas. So let's take a look. So I notice immediately the first formula that's described right here, this is the arc length, and the second formula is the formula for the area of a sector. If I perhaps maybe rearrange some things, right, and simplify this, I notice that 2 over 360 just gets me 180, right? So look at this closely. Theta pi over 180. Where have we seen that before? That's right. This is, in fact, the conversion going from degrees to radians. So it is actually a very natural thing for us to do to rewrite this ratio simply as a radian measure. So in other words, the arc length is the measure of the central angle in radians multiplied by the radius. Similarly, I can take the area of a sector formula and do the same thing. I can take this and do a little bit of rearranging. Isn't 180 times 2 the same thing as 360? And isn't this right here just the formula to convert from degrees to radians? So as a matter of fact, this can all be reduced down to 1/2 alpha times r squared. Again, alpha is the angle in radians. So I don't know about you, but this is a very, very clean looking formula. It's very elegant, okay, it's simple. Same thing with this. Here are the formulas, again, that we've covered in the past 2 lessons involving arc length and area of a sector. So if you're given something in degree measure, okay, you would use the formulas in this column here. If you're given something in radian measures, you would use the formula there. Let's take a look at some examples. The area of a sector in this diagram is given to be 5 pi. You're asked to do 2 things. You're asked to find out what is the measure of the central angle, and then you're asked to find out what is the arc length. I did not specify what unit to use, whether to work in degrees or radians. Let's try to do both. Pause the video to see if you can figure this out. So to find out what the central angle is, if I know that I have an area as 5 pi, I can easily just go and apply the formula. I know that 5 pi will equal to 1/2 alpha r squared. And I already know what r is, right? So that's 1/2 alpha times 4 squared. So reducing this further, I end up with 1/2 times 16, so that's 8 alpha. Or in other words, alpha is equal to 5 pi over 8. So this is the angle measure in radians. So what is it in degrees? So if I want to convert this from radians to degrees, the angle in degrees is going to be 5 pi over 8 times 180 over pi. And if I convert this further, I will notice that I will have 900 over 8. Right, because 5 times 180 is 900. Divide that by 8, what am I going to end up with? I will end up with 450 over 4, or 225 over 2, or this is going to be 112.5. This is going to be 112.5 degrees. And then similarly, I got to find out what the arc length is. So if I know the angle measure in radians, which I figured out over here, right, 5 pi over 8, arc length is simply 5 pi over 8 times the radius, which in this case is 4. So what is the arc length going to be? The arc length will simply be 5 pi over 2 inches. So in this solution that I got here, I did not reduce it. So 4 goes into both 20 and 8 to get me 5 pi over 2, again in inches.